Um, in this segment, what I want to look at is how do we graph the functions for absolute values. So let us look at our mother function. Let us say y is equal to the absolute value of x. All right, we're going to approach this by using a table quickly to see the values that we get, right? All right, so here is it. Let us say we have a table. I'm going to put values from -3 all the way to +3. So finding the absolute value of this, I'm going to substitute each one of these values where the x is right here. So the absolute value of -3 would contain +3. The absolute value of -2 is 2. The absolute value of -1 is 1. And of 0 is 0. 1, 2, 3. So the absolute value of all of those numbers that we have, they're all positive. We're supposed to drop this on a grid x, y. So -3 goes with 3, this right here. -3 goes with 3 right here. -2 goes with 2 here. -1 with 1. 0 with 0. 1 with 1. 2 with 2. 3 with 3. If we take a quick look at what's going on here, there, and you can see it looks like a V. We're getting a V shape. All right, the general idea format is y is equal to a absolute value of x minus h plus k. And in this case, our vertex, which is the imperative part of the graph to understand where the vertex is, right, is right here, right there. Our vertex is actually, the coordinate is h and k. And notice this is a minus h, but the vertex is positive h. So it is actually the opposite of any number we have here for h, right? All right. So we're going to keep this graph here. And what we want to do is to look on what if I have a negative here in front of the absolute value sign. We're going to run a table quickly and see what we get. Imagine if I substitute here. If I put a negative number here, I'm going to get a positive response because the absolute value of all numbers will be positive. But there's a negative in front, which is going to change it back to -3. This is going to be -2, -1, 0, -1, -2, -3. The bottom line is the absolute value of all of these, it's positive. But this negative sign is going to negate them, turn it back into negative. Let's go ahead and plot these points. All right, so -3 with -3, so let me put -1, -2, -3. So -3 with -3 is here. -2, -2 is here. -1, -1, 0, 0, 1, -1, 2, -2, 3, -3. Let's take a look at what we notice happen here. All right, so you do notice that the graph in blue is, so this one in black here is absolute value y is equal to, so y is equal to the absolute value of x, while this one is y is equal to negative absolute value of x. And you can see that what the negative sign does, it reflects the mother function in the x-axis. That's what it does. It reflects it in the x-axis. So there are two things that we want to take away from this. One, when we have a positive number for a, which is this, So when A is positive or absolute value, graph will be a V, but when A is negative, it's going to be a V that turns upside down. So we want to keep that in mind. So let us look on how we go about getting more ideas. First thing I want to do is to find my vertex. My vertex would be H and K. H will be coming from that. So there are two ways to get about that. We could set that to 0, solve for x, where x is -2. So we're seeing that my vertex is going to be -2 with 1. So it's either I'm just going to look at it and pick the opposite for it, or I could set it to 0 to find x. That is, it's like my axis of symmetry right there, -2. Fine. Now, let's go on the grid. Let's quickly drop an axis here. What I'm going to do here is to quickly identify the vertex first. So the vertex is at -2, 1. So -2, I'm going to put on the negative sign. So -2, 1 is right here. So that's my vertex. Now, another thing that we could do is to use our A value, because remember, y equal to A, x minus h plus k. This A value here can be used as our slope. So we could use it to understand how we're going to create the absolute value function. For example, the graph for it. So I'm not seeing a number here, which means that we have a 1 there, right? And a 1 would mean a 1 over 1, right? A rise and across. So from here, because there is a 1 here, which means 1 over 1, I'm going to go up 1 and to the right 1. My absolute value function would be like a V. So it means then from the vertex, I'm going to go up and go to the left, create that balance for it. So go up and across, I go up to the left, up to the right, and up and to the left. So we could see that being created there. So we could quickly draw the graph. Here's my vertex, here, there it is. And that's what we have. So what if we're asked to tell the domain of this? The domain would be the set of x values. I could see that all the x values could work. So it's going to be from negative infinity to positive infinity. Right? So those are the x values that can work from negative infinity to positive infinity. The good thing about the range is that the y value for my range will be a part of, right? That y value there from the vertex is a part of my range. So in this case, we're moving from 1 to positive infinity. And if you notice, I have a square parentheses here with square parentheses, which would suggest that 1 is a part of the whole solution set that we have here, right? So there we go. Let's look at another problem. First, I want to find my vertex. So my vertex is going to be 1 and -2. Because remember, the vertex is the opposite of this number here along with this. So it's +1, -2. From that, let me go on my grid for -1, -2, -3, -4, -5, x, y. Let's find this vertex. It's at 1, -2. So my vertex is right here. Right, so I have my vertex at 1, -2. Then, so from there, remember now that this number here, this is my A value, and it tells whether the curve would expand or whether it's gonna compress. But we can use this idea to help us to catch the other point. So we're gonna use it like the slope. Remember, it's negative. So if it's gonna be negative, we're gonna go down 2 and across 3. All right, so down 2, 1, 2, across 3, 1, 2, 3. That's 1 point. And I could do the same. So down 2, 1, 2, cross 3, 1, 2, 3, coming here. All right. And the moment I have that, then I'm good. I just draw a line through that. And there I have it. My absolute value will take on that shape. There it is. That's my absolute value graph right there. So the bottom line is we want to get the vertex. And from there, the A value could help us to navigate. Now, let us write what the domain is. You could see that all values on the x-axis can be used. So it's from negative infinity to positive infinity. The range, you can see the largest value is -2. So it's coming from negative infinity up to -2. And that's the range right there. All right. Again, I wanna first grab my vertex. And my vertex. So when we look at this situation here, I know that I have a 3 for my y, but the fact that I'm not seeing any h value, it means then that it's a 0. So it's at 0, 3. So what we want to do is to quickly get a grid, go at 0, 3. So 0, 3 is right here. All right. And that's my vertex here. If you look here, there's no number here, which means that there's number 1. So I'm going to say 1 over 1 to help us to navigate. So we're going to go up 1 across to the right, up 1 across to the left. I could stop, I could go if I want. So 1 over 1, rise, and then to the right, and then rise to the left. Connect them. We only need 2. The moment we connect them, there it is. So that's our function for that y is equal to the absolute value of x plus 3. What's my domain? It's the same all the time. Negative, positive infinity. What's my range? All right, so my range will start at positive 3 and it ends at positive infinity. So it goes towards positive infinity, should say. So basically that is how we graph absolute value functions.